Victoria Sims, and I'm a researcher at Ulster University. And my research particularly focuses on how children's thinking changes over time. My area of research would be described as developmental psychology, and this area of psychology has a long history. Look at these two images on the top of the slide. These were taken over 100 years ago, and they display two people who are very important in developmental psychology. On the left is a gentleman called Vygotsky, and on the right is Montessori. These two individuals were fascinated by how children think and how they change over time. Vygotsky suggested that children learn best in social environments, when they're working together with their peers and when they're working together with adults. Montessori suggested that children learn best when they play with actual objects such as water, stones, and bowls. I love to think about Montessori and Vygotsky and wonder if they could ever have imagined the types of things that our young children are exposed to and the access that they have to so many different things in their environment nowadays. For example, how fascinated they would be by a child engaging with a piece of digital technology, just as this toddler is doing in the picture on the bottom right-hand side of the screen. But also in terms of child development and the historical context of how children learn, our children nowadays are very similar to those children 100 years ago. And we can see this image on the bottom left-hand side of the screen of 4 children playing together with very simple wooden blocks. So developmental psychology has changed over time, but really what we want to do as developmental psychologists is to understand the influence of genetics, of children's cognitive skills, their thinking skills, and their environment, and how these lead to children learning information about the world they live in. A particular interest of mine is how individuals process numerical information. And there is a great suggestion from lots of research that's gone on in the area of developmental psychology that our brain is hardwired or is specialised to be able to process numerical information. Here is an image of a human brain, and we can see that the brain is divided up into different sections. From the frontal lobe, just behind your forehead, the parietal lobe, the occipital lobe, which is at the back of your head, and the temporal lobe, which kind of runs above your ear. And we know that different areas of the brain are more important for certain types of information than others. So for example, when you're having to plan something, like organise cooking dinner, you have lots of activity going on in the frontal lobe. What we have found in our research programme is that there is a specific part of the brain that is particularly important for processing numerical information. At Ulster, we are particularly privileged to have access to an incredible piece of technology called the MEG. This MEG, or magnetoencephalography machine, allows us to take video footage of the brain in action. So we can present on a screen, as this individual is doing, on the left-hand side of the screen, being presented with information and processing that information in their brain, and we can take a video image of their brain whilst they're doing that. And the image in the middle of the screen shows us a particularly important area when we ask people to do a task that requires them to process numerical information, and that's the intraparietal sulcus, and it's highlighted in red. From a study that we have just completed with some adults within the MEG scanner, we found that no matter what type of format we present individuals with in terms of numerical information, so that could be digits, that could be number words, or it could just be sets of dots, they use similar parts of the brain to process this information. It really enables us to think about the specialisation of the brain, that certain areas are more useful to process certain information than others. And really, at Ulster University, we have been enabled to do this piece of research using a piece of technology that is only one on the island of Ireland and is only one of a very small number across the world. So we have a really exciting research programme going on within the university, understanding the brain, its functions, and its specialisations for certain types of information. Another core component of my research programme is working with children to understand what thinking skills are important for mathematical development. And we do this by tracking children over time. So we recruit children into studies and we aim to follow them up over time, maybe every 3 months, maybe every 6 months, or maybe even every year. And we have found out lots of information about the thinking skills that are important for mathematical development. We know that 4 kind of subsections of thinking skills are important. And the first one is working memory. How do we measure working memory? Well, we can do tasks just like this one on the screen. And we ask children to watch a screen with some cubes on it, and the cubes light up in order. So number 1, number 2, number 3, number 4, number 5. And then we ask the children to tap the blocks in the same order that they lit up. And what children are having to do there is to make a mental picture of what they have seen and then use that information to be able to indicate their response. And that helps us understand children's working memory. Our working memory is something about how we store information in our minds and we process that information. And what we have found is that children who have more sophisticated working memory skills, who have better working memory skills, show better mathematical development. We've also looked at children's visuospatial skills and how that relates to mathematical development. And this is a really nice example of a visuospatial skills in the right-hand side in the top box. Here we show individuals the grey object and we ask them to indicate which one of the 2 red objects matches the grey object. And what they have to do here is to rotate either the grey or the red objects around in their head to perform that match. And that's visuospatial skills. Another task that we can do is show individuals a flattened object, a 2D object, and then show them some 3D objects and try to see if they can use their visuospatial skills to indicate which of the 3D objects matches the 2D object. It's very complex, but you're having to do lots of mapping in your mind, and we know that children who have more sophisticated visuospatial skills also have better mathematical skills. Additionally, we have found that inhibitory control is very important for mathematical development. And inhibitory control is the kind of thing that you use all the time to hold back saying something that you really want to say but might be very inappropriate. So for example, in a classroom, in a primary school classroom, when a teacher asks a question, children are using inhibitory control to prevent themselves from shouting out the answer and instead putting their hand up to answer the question. A really classic example of an inhibitory control task is this picture that we have in the bottom left-hand side of the screen of a child being presented with a sweet, a marshmallow, and being told that they're not allowed to eat the sweet, and we can time how long it takes for the child to grab the sweet, to lose their ability to control themselves. And what we found, and many other researchers have found, is that children who display better inhibitory control also show better mathematics skills. Finally, how we think about numbers is also very important. So in my research, I use a task called a number line estimation task, where we present children with a number line, for example from 0 to 10, and we ask them to position a series of numbers on the number line. And what we find is that children who are more accurate at doing this task also show better, more sophisticated mathematical skills. Finally, we know that anxiety hinders performance. So children who have poor attitudes towards mathematics, who are very anxious about mathematics, show worse mathematical performance than their friends who aren't so worried about mathematics. And we believe that this anxiety about mathematics affects children's working memory in order to be able to perform mathematics to their best ability. We also know that some children just find mathematics very difficult. And we have done research in my research group, along with some individuals from other institutions across the United Kingdom, working with a specific group of children who seem to have difficulties with mathematics. And this group of children are children who are born very preterm. So these children are born at least 3 months early. They come as a surprise to their parents. And what we have done as a research team is follow these children up when they're in the late primary school and in early secondary school. And what we have observed is these children do struggle with mathematics as a group. Not all of them struggle, but a lot of them struggle. And the reason for this difficulty with mathematics appears to be something that was on the previous slide. problems with working memory, being able to hold things in their mind and do something with that information, and their visuospatial skills, being able to do these very complex mental processing tasks. This seems to be consistent when children are in primary school and also when children are in secondary school. So all that research is very interesting, but what do we do with that research? Well, as academics, as scientists, we publish that research and we publish books basically for our scientific colleagues. But also we use this information to change children's lives, to help support children in their learning. So specifically what we want to do, especially with the work that we do with preschoolers, where we follow them up over time, we want to support parents to be able to help them help their children learn to the best of their capabilities. We want to inform teachers about the types of issues children may be facing in the classroom and help suggest techniques that may improve children's performance. So for example, in terms of the children who were born very preterm, we've developed a lovely resource for teachers to learn about the types of issues very preterm children may face in the classroom and strategies that they can use in the classroom to help support very preterm children's learning. And finally, as a scientist, I really just want to encourage children to enjoy mathematics, to enjoy using mathematical material, and to get a real kick out of doing these types of problem-solving tasks. So, I just want to thank you for listening to my presentation, and if you have any questions, please contact me on v.sims@ulster.ac.uk or tweet me at Dr. Vic Sims.